Welcome to this little extra video for section 7.1. I know we talked in class about using our rational root theorem list to solve polynomial equations, but I wanted to give you a couple more examples in case you want a little bit of help with the homework tonight to do that. So I'll do a couple more problems with you, different than the ones in class and are on your homework, and we'll see where we go with this. So let's start with a function, f of x equals x cubed plus 7x squared plus 4x minus 12. And again, we want to find all the zeros. So essentially what we're being asked to do is we want to set this equation equal to 0 and solve for x. Now, as we talked about before in class, through the fundamental theorem of algebra, we know that because this is a degree 3 polynomial, we expect 3 roots. So we're not going to stop till we find all 3 roots. The next thing we can do, because of the rational root theorem from the other day, we can now make a list of all the possible roots that this function can have, at least the rational ones. So we would use the factors of the constant divided by the factors of the leading coefficient. Well, since the leading coefficient is 1, we just have to worry about the negative 12. So the factors of 12 are 1, 2, 3, 4, 6, and 12. So I've got 2, 4, 6, 8, 10, 12 different numbers I can choose. All right, let's set up our completing the square, let's set up our synthetic division table. So we'll take all our coefficients, and we'll put our little corner box. So we're going to pick numbers from this list that I just circled, and we're going to put them in that corner box until we get a remainder of 0. All right? So we can try and guess and check. We can look at a graph too, and we can look at some x-intercepts on the graph if we have our graphing calculator. Why don't we try 1? Okay, so 1 goes in the box, and we do synthetic division. So that first column, 1 comes down, we multiply by the 1 in the box, we add and we get 8. We multiply again, we add and we get 12. We multiply by 1, and I got lucky. 1 works. So x equals 1 is one of my roots. Now what I need to do is I need to replace the numbers in this bottom row as a polynomial. So I have 1x squared plus 8x plus 12, and I want to solve that now for 0. Since it's a quadratic, it's an x squared, we can certainly factor this down. We can think about 2 numbers that are going to multiply to 12 and add to 8. And we can think about that. Well, it's not going to be 12 and 1. It's not going to be 4 and 3. How about 6 and 2? Oh yeah, that works. So we can set each factor equal to 0. So x plus 6 can equal 0. X plus 2 can equal 0. So x would equal negative 2 and negative 6. So there are your 3 roots. We can now say definitively that the 3 roots of this given polynomial are x equals 1, negative 6, and negative 2. Which also means if we wanted to factor that given polynomial, our factors would be x minus 1, x plus 6, and x plus 2. If you FOILed these 3 factors out, you'd get the original problem. Let's try one more. Let's try a 4th degree one, just to get the hang of doing this a couple times, this synthetic division. All right, so why don't we do g of x equals x to the 4th plus 4x cubed minus 3x squared minus 14x minus 8. Okay? So again, when I'm given a problem like this and I'm asked for my zeros, it means I'm going to set this equation equal to 0 and try to solve for x. Before I jump right in and do any guessing and checking, what I need to do is I need to think about, well, what kinds of guesses do I want to make? How many answers do I expect? So, looking at this, we now see that It's a degree 4, so we're expecting 4 roots. Now, if we get our possible rational roots, again, we're going to look at factors of just 8. Since I don't have a coefficient in front of the leading term, I don't have to worry about p over q here. And the factors of 8 are 1, 2, 4, and 8. All right, so there's not as many to check in this example, but we do have to get 4 answers. So, if you want, feel free to go to your calculator and take a look at some of those x-intercepts of the graph of x to the 4th plus 4x cubed minus 3x squared minus 14x minus 8, and use some of those x-intercepts as some of your first guesses. Okay? I don't have that in front of me, but I'm going to just try and guess. So why don't I guess 2? Okay, so I'll bring down the 1. Add to the 4 gets me 6. 6 times 2 is 12. Adds to 9. 9 times 12 is 8. That adds to 4. Oh, I got lucky here guessing. Okay, so x equals 2 is one of my roots. All right, 1 down, 3 to go. So at this point, now I have x cubed plus 6x squared plus 9x plus 4 I want to set equal to 0. And I can't really solve that with any other method other than trying synthetic division all over again. So why don't I do that and try synthetic division all over again? So I'll put my 1, 6, 9, and 4. And I can still use that list from the last page, 1, 2, 4, and 8, and I can try again. How about we try 1? So I'll bring down the 1. 1 times 1 is 1. 6 plus 1 is 7. 7 times 1 is 7. 16, I don't think that's going to work. I think that's going to get me too big. I'm not going to get a remainder of 0. All right, well, we'll try all over again. How about we use negative 1? 1 comes down. 1 times negative 1 is negative 1. That adds to 5. 5 times negative 1 is negative 5. That adds to 4. Oh, that worked. So x equals negative 1 does indeed work. Now, if we look at the 3 numbers that are left here, we can now write our depressed polynomial, and it's going to be a quadratic again. X squared plus 5x plus 4 equals 0. And I can factor that. What multiplies to 4 and adds to 5? X plus 4 and x plus 1. When I set each of those factors equal to 0, I get x equals negative 4 and x equals negative 1. So, my 4 roots are x equals negative 1, x equals negative 4, x equals negative 1? How did I get it twice? We're going to talk more about this in class, but this is what we call a double root. So what ends up happening is you end up having a repeated factor in your problem. So technically there's only 3 unique answers to the equation, but there are technically 4 roots and 4 factors. Okay, and then the 4th one that we had was x equals 2 from the previous slide. So that means the 4th degree polynomial that we started the problem with, x to the 4th plus 4x cubed minus 3x squared minus 14x plus or minus 8 is factored to be x plus 1, another x plus 1, that's the double root, x plus 4, and x minus 2. Okay, so there's still 4 factors and 4 roots, it's just 1 repeats here. Hopefully this gives you a couple more examples so you can tackle some of the problems we do in this section and in the future sections we cover with this. If you have any questions, please feel free to let me know. Otherwise, I will see you in class. Thank you for watching.